Very good. So it is our pleasure to welcome Mr. Richard Kaberdam. He is a heavy lift specialist from Kaberdam Advice Services.
When you see this block lays on the table, and it's there, but the Earth is pulling to that mass. If that block represents a mass of 1 kilogram, the Earth is pulling on that always the same. It depends on where you are. For instance, on the Moon, it's only 1/6 of what it is here on our. What is it now? Is it a fully loaded or an empty trailer?
Empty.
Empty? Full? Who says empty?
Empty.
Who says full?
I said full before, not now.
Okay, now that's right. You have to be a little bit more patient, huh? Right. Now it's basically very simple. Why did this trailer?
What's going on here?
What the hell is going on here? Here's a big bang, and then watch what happens.
Watch it!
It's breaking something. Now these people here in the man basket get hit by the crane and they fall down and they're killed. 3 people that died. Oops. Friction force, yeah, there we go. And we calculate that. And now first of all we have to find out how much is Fm. We take this load, 50 tons, and you take it, this is 1, so this is 50 tons divided by √2, remember? The standard try. If you want us to bid for lifting and transport as well, we need to know where the lifting points and the transport saddles are on the load. We want to know the foundation on which it has to be placed. The location of the center of gravity in relation to the saddles or the lifting points. The infrastructure of the job site. Loading and unloading key. What is the height of the key? Key levels, water depths, port location, swell and no swell. We come to those parts as well. So again, it depends on how much load do you put on the trailer. But I hope that I get across and over to you the difference between 3 and 4 point and what are the criteria and why you should use this and why you should use that. And of course, more and more trailer operators are using the 3-point suspension of the hydraulics of the trailer. And then you roll on. Now you see here that he is having difficulty in pushing it the last end. Again, how do you define the needed pulling location of personnel? Watch for yourself, but also watch for your colleague. And tell a colleague when he's standing in the wrong position, get out of the way there. Do not stand between a wall, a solid wall, and a load when you're lifting it. Because if it happens like we just showed, if it hits the wall, you're stuck between the wall and the load, you're dead. And it has an effect on the distances A and B, and that makes the difference in the tail load. Yeah. So make use also of the decrease of the tail load. What I've just seen in that Excel sheet, you can use that to your advantage and position the crane in such a way that it can lift maximum here, and when it swings out, that here already it starts decreasing the load and that it is in this position still within capacity. It's just a matter of optimizing it on the drawing board and saying where do I put the crane. Another point is, and that's what you were saying, under the line. What does that mean? It means, if I take one string, the center of gravity, which is here, is again on the line, the vertical through my, okay, very good. This is one sling, the red one is one line, so the 50 ton here is still 50 ton there.
The tail crane carefully swings the top of the column between both boom heads. 82 meters and 512 tons is now fully suspended by both TC3000 cranes and can be lowered onto its foundation.
What are you doing?
Crane and heavy-duty cables to hoist the 14-ton bus back onto the
crane.
and rips the crane down with it.
Nobody got killed.
Take another look. The crane operator manages to lift the bus almost completely out of the water. The hooking machine is unable to support the tremendous weight of the flood. The bus plunges back into the river and pulls.
Now what kind of crane do you think that is? The next day, final route indicators were painted on the road. The second prime mover was held on standby in case extra pulling force was needed during this tight turn. With a few times repositioning of prime movers, the freight train's crew managed to get the enormous load underneath the pipe rack in the direction of the next turn. Thursday afternoon, the 15th of July, around 5 o'clock, the 790 tons reactor was successfully delivered and they reached the American Skyhorse crane. As a token of appreciation for a job well done, the project teams were congratulated by the Reliance Managing Director.
They start up,